Hello friends, today in the class I am going to demonstrate how to use a Vernier slide calipers. And this is a device where you can measure the diameter of a spherical body, then length, breadth, height of a cube, or diameter of a hollow cylinder or solid cylinder. But instead of having the linear scale, why do you use this? This is a device where we can measure precisely. In case of linear scale, you can measure minimum up to 1 millimeter, but here beyond that you can measure. Now see, these Vernier slide calipers, when I connect these two jaws, okay, then if see, the main scale 0 is coinciding with the Vernier scale. Okay. Now see here, there are 10 division of Vernier coinciding with 9 scale main scale division. See, 9 main scale division they are coinciding. But depending upon different devices, you can have say 50 Vernier division coincided with 49 main scale also. We have like that also. But here we are just going to show in this apparatus. See this 10 Vernier scale is coinciding with 9 main scale division. So we have to find out what is the difference between one main scale and one Vernier scale. See, the difference between this one main scale and this one Vernier scale is known as the Vernier constant. So we have to first find the Vernier constant. So what is the Vernier constant? It is the difference between one main scale division and one Vernier scale division. And again, if two jaws are in contact, okay, and main scale 0 is coinciding with Vernier scale 0, then no error in the apparatus. There is no error in the apparatus. But if after the jaws are in contact and you find that suppose this Vernier 0 is towards the left or towards the right side of the main scale 0, then instrument is said to be have an instrumental error. Okay. Now let us see how to take the measurement. And before that, I have to give the theory in the board. Suppose we are going to measure the length of this cube. Okay. Then we'll place the cube at the lower jaws like this. Now see in the figure. Okay. Suppose this is the cube, and this is your Vernier scale. This is the main scale. This is the main scale, and this is your Vernier scale. Now, as I told you at the very beginning, the 10 Vernier coincide with 9 main scale. Suppose n Vernier scale, if we find in Vernier scale division coincide with n minus 1 main scale division, or 1 Vernier scale division represents n minus 1 by n main scale division. Therefore, the Vernier constant, as I told you, that it is the difference between one main scale division to one Vernier scale division. So, substituting this, we get this. Or see, this Vernier constant, I can substitute. See, after calculation, we have this. So, 1 by n into smallest value of one smallest main scale division. Okay. And in our device, we have 10 Vernier scale division equal to 9 main scale division. So, Vernier constant will be 1 by 10. See, 1 by 10. Here for n, I am putting 10. So, this value of this scale, main scale is 1 millimeter. So, I get 0.1 millimeter or 0.01 centimeter. As the number of division increases, number of Vernier scale division increases, the smallest the value of the Vernier constant means more accuracy of the device. Now see, we are going to measure the length of this cube, and it is placed in the lower jaws. Now see, before the Vernier scale, Vernier 0, this is the Vernier 0. Before Vernier 0, up to what we have seen the main scale? This no? Means 3.8. Okay. Before Vernier 0, up to what main scale you have seen, this is. So 3.8 is the main scale division. And see which Vernier division is coinciding with the main scale, and that will be your Vernier scale reading. Here in the figure you see this Vernier same 7 division is coinciding with the main scale. So Vernier scale reading is 7. So you now multiply the Vernier scale with the Vernier constant, value of Vernier constant. Vernier constant is 0.01. So 8 into 0.01, that is the your value of Vernier scale reading. So you add main scale reading and value of Vernier scale reading. So what we have got 3.8 0.87 is the main scale reading, our observed length of this cube. So to get the correct result, accurate result, we take 3 observations: first position of the length, second position in the middle, then third position. So we take 3 different positions. Similarly, we can measure the breadth. This is the first position of the breadth. At the middle, it is the second position. At extreme position, third position. So we take 3 observations to get the correct result. As taking the observation in main scale and vernier scale is similar to that as we measured in case of length. Okay. So then we'll measure the height. Similar to breadth, we can measure the height, first position of the height, at the middle, second position of the height, and third position of the height. So now we have measured 3 quantities: length, breadth, and height. And already we have learned how to take the observation with the vernier slide calipers. Then we can find the volume of this cube. After finding the volume, we can find the density of this cube also.